All right, it's time for lab 5. So this is going to be a functions lab, not a classes lab. That'll be later. This one is on a cool thing called rational numbers. All right, so first of all, the phrase rational number is just a pretentious way of saying fraction. All right, so like a rational number is the ratio of two numbers. So a over b, that's just what a fraction means, right? So a rational number is just a fraction where there's like a whole number on the top and a whole number on the bottom. And we're going to make a library that works with these rational numbers, all right? It would be nice, though, to work with them as simplified rational numbers, because you know, like 2 over 4 is the same as 1 over 2. Like you want to like simplify things as much as possible. I'll show you how to do that. Yeah, we'll also work with like, it's easy to multiply two fractions, right? Addition is a little hard because you have to find like a common denominator, so we'll get into that later. But yeah, rational numbers is just a ratio of two numbers. It's a fraction. All right, so the starter code looks like this. I got a few things, and here's the library, and here's two separate files. This one has a main function, this one has a main function. So you can't compile all these together. It's like either you use this program that runs the library, or you use this one that runs the library. All right, I'll talk about both. They're just meant to help. The first one is just meant to help you. You're not going to turn this one in. So like you're going to get this one working with your library before like you run all my real tests over here. That's going to be the goal. So yeah. Your job is to make a rational number library. So rationals.h has the declarations of everything. You're going to implement everything in that file in rationals.cpp. All right, it's just like we've been doing in class. All right, so here's rationals.h. Well, let's talk about it. Here's how I want you to implement your library. All right, so there's a few things that you're going to be doing. So the first one is like we'd like to be able to print out our rational numbers in a pretty way. So like every rational number that we get, every fraction that we get has a numerator and a denominator. So here's how we're going to use our library. We're going to get both of those things, and then the job of this function is to create a pretty looking string that was the fraction. So like it'll put a slash and some spaces, like it'll convert this fraction to a string. All right, there's that one. And then this one is rational times. It multiplies two fractions. So here's your first fraction, numerator and denominator for it. Here's your second fraction. And then to return the third fraction, the result fraction, I've used reference parameters. So you can just mess with these variables and it will set whoever made space for them. All right, so you just set these, and that's a way to give back multiple things. You just change what was there because you're getting them as a reference. So that's the multiplication. And then here's a very important one, simplify. So if you give it a rational number by reference, it will change the numerator and the denominator to be the most simplified version of it. Okay, so that's rationals.h. All right, now rationals.cpp is where you implement stuff. All right, and let me show you that file. So rationals.cpp is where you implement all the library stuff. And so I've given you a bunch of fix me's. I've started you off, and it's your job to fix them now. All right, so you're welcome. There is one helper function that I've already made. This one's already correct. It's called GCD, greatest common divisor. Remember that from class? It finds the biggest number that goes into both numbers. So here is why you need that. All right, so you're going to need that to do simplification. So here, I need to mark this up now. So for your lab, here's what I'm talking about. So say that this is your numerator and your denominator, 2 over 4, right? That's not simplified. You'd like that to turn into 1 over 2. You can do that with the GCD. Do you see how if you give your fraction 2 and 4 to the GCD, you ask for the GCD of 2 and 4, the biggest number that goes into both of them is 2. It will give back 2. And do you see how if you were to divide by that 2, that would give you 1/2? Hoo-hoo. That's the secret, all right? That's the trick. So that's what you need to use GCD for. And so simplifying is probably the first thing that you should write. Okay, that's the first function that you should write and implement to take your original rational number and simplify it to a different one. Okay. I do want to tell you to be careful that let's see. GCD only works on positive numbers, positive, non-zero, non-negative at least. It can be 0. That's fine. But GCD will not work with negative numbers. It will do the wrong thing. All right, so you're gonna have to get rid of negative stuff in a certain way. And then also for simplify, you need to like cancel out some negatives as well. So for example, your simplification should do like it should be able to handle like -1 over -2. Like that should be turning into 1/2. All right, or like 4 over negative 8, we're going to assume that like the negative in the most pretty way should always be on the top. So also as part of your simplification, you'll just make the numerator negative, not the denominator. So if you were given this, you'll both simplify it and also move the negative to the top. All right. So that's this will be turning into negative 1 over 2. The numerator becomes negative if the fraction is negative. All right. So that's what you're going to do. And so before you call GCD on your numerator and denominator, you need to make sure that they are not negative. All right. So you have to get rid of the negativity like with the absolute value, because otherwise GCD won't work. You can't just like shove 4 and negative 8 into GCD. It will not do the right thing. Okay. So with that, here's kind of how I want you to implement it. You'll have to figure out if it's negative. Figure out if your fraction is negative, because it might not be. So like, for example, this fraction has negative in both halves of it, but it's not negative, is it? So you have to figure out the all the canceling and things. All right, so here are your cases. So like if your numerator is negative and your denominator isn't, then your fraction was negative. If your numerator was positive or 0, but your denominator was negative, like if only one side and it was the denominator this time that was negative, then the whole fraction is negative. But if neither of those are true, so either both sides are positive or both sides are negative, then your fraction is positive. You see that? Save that in like a bool. Call it like bool is negative or something. Save that. Because now you need to make numerator and denom positive. You have to use absolute value, or just make them non-zero at least. You have to use absolute value so that you can do GCD. All right? That's what has to happen right now. So convert them to positive numbers, otherwise the GCD won't work. Save the fact that the thing was negative or wasn't negative up here in like a bool, all right? Because then you can do the simplification. You can be like, all right, I'll do the division, make this thing, and then if it was supposed to be negative, you just like use your bool to notice that and attach a negative sign to the top, okay? That's what you're gonna do. So simplify numerator and denom using GCD, and then if it was negative, numerator should be the thing that's negative. And that's it. Because you took these things by reference, you just changed them, and that messed with the fraction that needed to be changed. It's done. That's simplification. And then, yeah, the rest is not too bad, I think. Now, multiplication of fractions, like here are your two fractions. Multiply them into this thing. Result numerator, result denom. That's you're getting those by reference. And yeah, it's just, this is the algorithm, right? This is how you multiply fractions. A over B times C over D. That's just AC over BD, right? You do want to simplify this though. That's the last step. So once you've done that, simplify. So you'll just like take your answer, you put it in here, and then you can call simplify on that to mess with those actual values, right? I hope that makes sense. Just make sure to remember to simplify before you are done. And then your final one is pretty string. All right, so you want to return a neat looking string of your rational number. So you also want to simplify. So please simplify your fraction before you convert it into a string, but it's like you're given a fraction, you make a string out of it. All right. So for example, if your numerator, like you were given the numerator of 2 and the denom of negative 44, that will simplify to negative 1 over 22, and then you should return this string. You're not printing anything, you're returning a string. No cout anywhere, okay? You're returning this exact string so that somebody else can print it later, all right? That's what it should be. And so like it's just like the numerator, a space, a slash, a space, the denominator, all right? That's what you need to do. And so if this was your fraction, then you'll make it 1 over 2 with some spaces in between. That's the pretty way that you're going to make the string, all right? To do that, you will need to turn your numbers into text, because you need to add strings together, don't you? So the way to turn numbers into text is there's a toString function in the string library that's already been included for you. And if you call that on a number, it gives you back the string version of that number. So then you can add those characters to other things. So that's what you'll need to be using, all right? That's just in the string library. It's called toString. You give it a number, it gives you back the string form of it. And yeah, so that's what pretty string should do. You'll return something normal. All right, I just said stub here. You want to delete this line. A stub implementation is not correct. Okay, so I think that's all that I wanted to say for those. Those are the functions that you'll be making. Yeah, just remember that rational pretty string returns the string. It does not print anything. It returns the string. Somebody else prints it later. All right. And so yeah, I've given you a couple things. I've given you 2 files that you could compile your library with. I've given you sampleprogram.cvp, that has a main function, and test.cvp, that also has a main function. You cannot compile these both together. It will yell at you, all right? So you got to pick one. Let's say that I think I want you to do sample program first. So compile that one with your library, sample program with your library, And here's what it should look like. It's just a program to let you test things. It's like it lets you type in your fraction, and it starts calling your stuff to make sure it does the right thing. Calls pretty string and tries to simplify it after multiplying it. See how it's doing? It's calling your things. So, like, for example, if you were to type these things, type these fractions in, like, you should see this as your output. And so that'll help you get it right, okay? So the sample program is not something you'll turn in. You can change it as much as you want. It's just my gift to you to try to help you debug, okay? So use that to your advantage. And then I've also given you another file that has, like, real tests. I do want you to get this stuff working first in the sample program, because otherwise the tests might not make enough sense to you. So yeah, after you've got the sample program looking right, then you can run the tests that I've made in test.cpp. So that's a completely different main function, so you're going to compile it like this, right? Give that with the library now. Compile it like that, and then I've got a bunch of tests that I've given to you. All right, so here are your tests for, I'm giving you one for like simplify and test multiplication, test rational pretty string. So here I'm using assert true, right? So this is exactly why your pretty string shouldn't be printing anything, because I'm comparing it to the string. See that? I'm not printing anything. So that's those are my tests there, just making sure that everything's right. Like this becomes simplified to -1/22, as it should have been. The multiplication does the right thing and also simplifies, gets rid of the double negatives or anything. And same with this kind of stuff. Okay, so simplification before making the string out of it, because 7/-49 needs to turn into -1/7. I hope you see all that. So those are my tests. Definitely get those passing, because I'll be running those on the autograder. And then it's your job to write your own tests. So make sure you start this early, right? You see all the different pieces of this lab. So I want you to write some tests in my kind of style. So like make some more functions and call assert true. I would like you to write 2 more tests, please. You can make some combination, maybe like multiply a bunch of fractions into a final answer. That might be a good test, for example. So like I want you to write, please, 2 more tests in the same kind of style and get them to pass in main. All right, and that's your lab. Okay, so I want to see assert true called twice by you. Those are your 2 tests. So passed should be printing 5 times exactly, 3 times for my tests and 2 times for your tests. No more, no less. All right, and that's it. Once you got your own tests passing, you're going to turn in everything that you worked on. So you're not allowed to touch the header file as well. Oops. The header file is not something you're turning in. I'm going to be grading you with this exact file, so do not change this one. See how you're not turning it in? So the one you will mess with is the implementation file, rationals.cpp. The sample program you're not turning in, so you can change that all you want. I'm not going to use that as I test you. And then test.cpp is the other one you're turning in. So your library implementation file and the test file where you wrote your additional tests. So those are the 2 files that you'll turn in for the lab. Everything else you keep yourself. Okay? So yeah, just remember to not change the header file. Don't add stuff there, because I'm going to be testing you with the default header file. I think that's all that I wanted to say. So please start early. You see that there's a lot going on for this lab. And I think that's all that I wanted to say. So good luck. Let me know if you have any questions, and I'll see you later.